All right, let's take a look at Trig Chapter 1, Section 4. What we want to do is we want to simplify fractions with radicals. Now, before we do that, let's take a look at adding fractions. This says I have 2/11ths plus 3/11ths. So how much do you have? If you have 2/11ths and then 3/11ths, what do you have? Well, we have a grand total of 5/11ths. Remember, when you add fractions, the denominator stays because that's what you're counting by. So in that case, 5/11ths. Well, what do we have? N over 7 plus 2 over 7. Well, you know you have sevens because you're counting by sevens. So we know, hey, that's just N plus 2 over 7. Okay, that's what we have. That's how we add fractions. If they have the same denominator, we're counting by the same thing. If they don't, we do have to get a common denominator so that we're counting by the same thing. So what if we have this? Well, this time I've given you the answer. Like back here, notice we have the answer of N plus 2 over the 7. Well, this time I'm giving you the answer and I want to break it back down to what the question was. So this would have been 2n over 10 plus 4 over 10. That's what we would have had. Well, notice that this can simplify each of those fractions. 2 and 10 both can be divided by 2, so they become a 1 and a 5. And 4/10 both can be divided by 2 and becomes that. I then, since they're both now fifths, I can put it back because that's an n over 5 plus a 2 over 5. So that's an n plus 2 over 5. That is a simplified answer to that. Now, do we always want to break it down into its parts? Well, sometimes you do. But we do find that it might be easier if we simply look at this and look at the 2, look at the 10, and look at the 4 and say, hey, what can they all be divided by? Now, all of them have to be able to be divisible by something. Otherwise, it's not going to simplify. And we'll look at that in a second. So I see 2, 10, and 4 all can be divided by 2. So it might be easier if we go ahead and say, hey, let's divide each of these by 2. 2 divided by 2 is 1. 10 divided by 2 is 5. 4 divided by 2 is 2. And then we can see that we end up with 1n, which is n, plus a 2 all over 5, which you'll notice is the same answer we ended up with right here. This is a little simpler to do. And that's the way we'll probably tackle the problems. Now, can we simplify this? Well, a lot of students will come in and go, oh, 2 and 4, let me just make it a 1 and a 2, so it's 5n plus 2 over 1, so 5n plus 2. No, unless every single one of the three pieces can be divided by the same thing, you cannot simplify it. You cannot divide that 2. That 2, remember, is dividing the 5 and the 4, okay? Because really that was 5n over 2 plus 4 over 2. That's what it really was if we separated it into its pieces. Now you could simplify this, which is just the number 2. And so it's 5n over 2 plus 2 whole units. But if all three can't simplify, you can't mess with it. So let's look at some examples here. 8n plus 12 divided by 6. What can 8, 6, and 12, all three of them, be divided by? They can all be divided by 2. So we'll divide every one of them by 2. That's a 4. 6 divided by 2 is 3. 12 divided by 2 is 6. So our answer ends up 4n plus 6 divided by 3. Now, if the 4, 3, and 6 all could be divided by something else again, you would to simplify it, which means you would have missed the greatest common factor that those three shared to begin with. Okay, now we're seeing it with the radicals, which is where we want to go. Before we can do anything, we have to simplify the square root of 20. And if you remember, we do that by doing a factor tree. So we have a 2 times 10, prime, so I'll circle it. 10, a 2, and a 5. So we know this is a 2 times 2 times 5. That's what square root of 20 is. And the 2 gets married as a pair, comes out as 1, so it's 2 root 5. So I'm going to relook at this as 8 plus 2 square root of 5 over 6. Now, don't ever try to do something inside that square root with this guy. He's inside the house. He can't be messed with. You do not want to do that. Okay? Don't ever try to do that. Only the 6 and the 2. Those guys, the outside number, those can be simplified together. Okay? So let's go ahead and do that. All we're concentrating on are the 8, the 2, and the 6. What can the 8, 2, and the 6 be divided by? They can all be divided by 2. So this becomes a 4. 2 divided by 2 is a 1. 6 divided by 2 is a 3. So our final answer, we have a 4 plus 1 times square root of 5. So we just write that as root 5 over 3. That's what it simplifies to. Let's do another example. So 8 plus the square root of negative 8. Now notice we're going to have an I here, an imaginary number. So if we break 8 down, that's 2 times 2 times 2. So a 2 is going to come out. So it's going to end up being a 2 comes out, and then the negative 1 comes out. Let me just do that really quickly. Excuse me. We have a negative 1 times 2 times 2 times 2 when we break down that square root of negative 8. So a 2 is going to come out. The negative 1 is going to come out as an I. So that's where we have the I, and then we're left behind with that 2 inside the square root, all divided by 4. Now, I look at the 8, the 2 that's outside, and the 4, and I say, hey, what can they all be divided by? They all can be divided by 2. So I'm going to divide every one of them by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. 4 divided by 2 is 2. Clean it up. I have 4 plus 1I, which is just I, times square root of 2, divided by 2. There, that is simplified. We have square root of 24 plus square root of 28, all divided by 2. If we break this down, I'm going to save you time. Square root of 24 looks like a 2 root 6. Okay. Square root of 28 looks like a 2 root 7, all divided by 2. Well, 2, 2, and 2. Now again, that 6 and that 2, never mess with somebody that's underneath the square root and somebody that isn't. You just do not do that. We're only looking at the 2, and the 2. Each of these can be divided by 2, which becomes 1, 1, and 1, which gives us square root of 6 plus square root of 7, all divided by 1, which if you divide anything by 1, it's itself, so you just don't mess with it. So there's our answer. All right, final problem here. 24x squared plus the square root of negative 20, all divided by 4. Well, if we write this out, we have 24x squared, and the bottom have a 4. What about the square root of 20? Well, that's going to simply be a 2. The I, the negative 1, comes out, and a 5. So now we take the 24, the 4, and the 2 and say, hey, what can they all be divided by? 2 is the largest thing by which they can be divided. So we're going to divide each of those numbers by 2. This becomes a 2. That's 12, and 2 divided by 1. So clean it up. I have 12x squared plus 1I, which is just I, root 5, all divided by 2. And there's our answer for that problem.